We're now looking at what's called a grouped frequency distribution. This is the most complicated of the four types of data organization tables or distributions that we use. This type of distribution is used for ratio or interval level data, which is quantitative. Okay. So let's begin. A group frequency distribution, a GFD, uses quantitative data, which is interval or ratio level data. One of the characteristics of this distribution is the classes have ranges of data rather than a single value. I'm going to make up a problem just to demonstrate what it will look like when we get done. And then we'll go through a problem from start to finish. As I said, this table is the most complicated. The first column is something called your class limits. Okay. The second column is occupied by something called the class boundaries. The third column will be our frequency. The fourth column will be our cumulative frequency. And the final column is something called our class midpoints. When we get the table done, we're going to create and draw 3 different graphs with this information. So we need various parts of this information for each of the graphs, which I'll describe as we go along. Okay? Now, I'm not going to bother with a bunch of data right now. I'm simply going to say, here's what it will look like had we already have our data and we make some decisions. Okay? So, for instance, suppose I'm talking about the age of students' parents. Okay? How old are your parents? Okay. Typical college students are 18, 19, 20, 21, 22, which puts your parents somewhere in the late 40s to mid 50s perhaps, maybe 60. So, let's start out with an age of 41. And suppose in this group we have someone who is 41, 42, 43, 44, 45. So we go from 41 to 45 in this group. Okay. And let's suppose in this group there are 2 parents in that age group. Okay. If a person is beyond 45, then they would be 46 or older. So this group is going to have 46, 47, 48, 49, 50. Okay. We'll say there's 3 parents in this group. The next group would start at 51. This started at 41 and went to 45, so this starts at 51 and goes to 55. And there's 7 parents in this group. Then 56 to 60, and finally 61 to 65. We'll say there's 10 parents in this group and 1 parent in that group. Okay. In the second example, I'm going to describe where these numbers came from. We find these numbers by looking at the actual data values, which I don't want to bother with now. Okay. So this will be the bottom of my table. In this problem, I have 5 separate classes, including parents from a low age of 41 to a high age of 65. Okay. Leave class boundaries for right now. Talk about cumulative frequency. Okay. We do need to know the frequency. If you remember, frequency is the sum of your sample size is the sum of the frequencies. So that's 2 and 3 is 5. 5 and 7 is 12. 22, 23. Okay. Cumulative frequency was the number of persons in that group and all previous groups. So the first value is 2, then 2 plus 3 would be 5, 5 plus 7 is 12, 12 and 10 is 22, 22 and 1 is 23. I'm putting the star here to represent that we do not total up those values. These are already being added as we go along, so we don't add them again. In our first column for class limits, we do not add these values either. Okay. Now I'll go over to class midpoints. Okay. Use a separate piece of paper here. The numbers 41 through 45, if I list them, 41, 42, 43, 44, 45. There are 5 numbers here. Okay? Since there are 5 numbers, this is called the class width. Okay? What I'm concerned with is where is the midpoint or the middle value in this group? The middle value would be 43. So the class midpoint for this first group is 43. Okay. Something unusual is happening here. If you were to take 41 plus 45 and add them, you'd get 86, and half of 86 is 43. You find the middle value of a collection of numbers in order by taking the first and last and averaging them together. Something important is happening here, if you noticed. Each of the numbers here, 45, 50, 55, 60, 65, I'm counting by 5. So each of these numbers is 5 more than the one before. The same thing is true here. 41 plus 5 is 46, 51, 56, 61. This is 5 is called the class width. If these numbers are 5 apart, then your class midpoints will be 5 apart. So 43 and 5 is 48, 48 and 5 is 53, then 58 and 63. And once again, we do not add these numbers. Okay. To find class boundaries, we need to think about what's happening from 45 to 46. A person may be 45.42 years old. Okay. So we'll say on a number line, from 45 to 46, let's examine what happens here. Okay. Half of between 45 and 46 is 45.5. Okay. So what we say is the boundary line between 45 and 46 is 45.5. For this first class, this is called the upper class limit of the first class, and this is called the lower class limit of the second class. We want the number halfway between those, so that would be 45.5. That becomes the boundary, the upper class boundary of the first group, and it also becomes the lower class boundary of the second group. So between 45 and 46, they have the same, essentially the same class boundary value. All these numbers are 5 apart, So all these numbers will be 5 apart. I can write 50.5, 55.5, 60.5, 65.5. It's important to notice the upper class boundary here becomes the lower class boundary there. So the 50 goes here, 55.5 goes here, 60.5 goes there. Now to get the lower class boundary here, we need to go below 41, and that becomes 40.5. One way of looking at this is if a parent were 40.5 years old, you could round their age up to 41. If a parent were almost 45.5 but not quite, you could round their age down to 45. Okay? This is how a group frequency distribution will look when the distribution is completed. Okay? In the next example, I'm going to show you where these numbers come from. Once you have these numbers and your frequencies, you can complete the other 3 columns of the tables. Stop video.